Hello everyone, myself Dr. Sonam Gupta, working as an associate professor in the Department of Computer Science and Engineering. So today I am going to discuss one complex topic in software project management, which is scheduling. Now, why scheduling is a complex topic in software project management? First and foremost, we need to identify and we need to understand that while completing any project, scheduling plays a very important role. Since if we are not able to schedule the project properly, then what will it lead? It will lead to the risk which can be evaluated. Along with this, it can be the thing that the project might not be completed on time, resulting in increase in the cost as well as increase in the effort from the project management. So it plays an important role. Now, what is scheduling? Scheduling is an important part of the project planning activity, and it involves deciding which task would be taken up when. Like in case of the scheduling, we need to identify that what are the tasks which need to be identified and when it need to be identified, like which task is to be taken up when. This is a very important keyword if we talk about scheduling. Like if I am developing a project and I have identified that there are 5 types of activities in the project. Now, my next challenge will be what type of activities needs to be taken care of, which activity needs to be started before any other activity. What are the activities that I can start simultaneously? Whether the simultaneous starting of any other activity will affect the other activity, what are the risks associated with it. So, for that the scheduling is an important activity. Now, why scheduling? The majority of the projects are completed late, if at all. Like this is the completed late. So, why the projects are being completed late? Because the scheduling of those projects have not been done properly. If the scheduling has not been done properly, then those projects will be late. And if the projects are late, then it might result in the cancellation of the projects as well. Next one, a project is scheduled is required to ensure that the project meet the commitments are met. The commitments which were done during the requirement analysis phase or during while we were fetching that particular project, whether all those commitments have been met or not. For that also scheduling is required. Third point, a schedule is required to track the progress of the towards achieving these commitments. Like if I'm not having a schedule, so how I'm going to track which particular activities have been completed, which activities needs to be taken care of since they are lagging behind the time, which are the activities that can be completed on time, which have been completed, which are not completed, for what activities I need to pull off more of the resources. So for that scheduling is required. Now, why software is delivered late? This is another important question that in the last slide I have said that the projects are completed late. Now, the next question which arises is why? What are the reasons why the project we say that the software it has been delivered late? First and the foremost, it is the unrealistic deadline. This is the major point while developing a project. See, when the deadline is decided, the deadline is decided after analysis of the requirements. Now, after analyzing the requirements, if we are not able to analysis all the requirements properly, or if the client is not able to tell its requirements completely, then it will result in an unrealistic deadline. What can happen? We can say, okay, the project can be completed within 2 weeks, but actually the project is not being able to complete it within 12 weeks as well. So, this is the unrealistic deadline that can occur. Next, it is changing but unpredicted customer requirements. So, as and when the project is progressing, since the customer is not able to identify his requirements, he is going to change the requirements again and again. So, changing requirement is another feature. Third one, underestimation of the efforts needed. So, the efforts which were done, underestimation has been done that okay, suppose 12 lines of code was required, but actually it was a amalgamation of many other technologies as well. So, this is underestimation of the efforts needed. Risk not considered at the project start. So, risk here it is an important part. If the risk has not been taken care of at the starting of the project, then what will happen? It will ultimately lead to late software, because whenever the risk will occur, we have to tackle that risk all my resources and all my manpower will go to handle those particular risks. Unforeseen technical difficulties. I'm not able to see what are the technical difficulties that can occur, like the server is placed somewhere else, the network is not working, the client, on the client side we are not having any developer. So these are the technical unforeseen difficulties. Unforeseen human difficulties, like I'm not having a developer for that particular technology in which the project is developed. In the starting of the phase, I was having a developer, but that developer has left the job, he has quit the job. So what will happen? I do not have any other person to work in that technology, so I do not have any backup for that human resource. So this is the human difficulty. Miscommunication among the project staff. Project staff, it is a huge staff to develop a project. We're having testers, developers, management team, designing team. So there are many other people as well. All the stakeholders are there. So there is no proper communication between the staff. That is also, it will lead directly to the delivered late project. Failure to recognize that the project is failing behind the schedule. We are not having a proper scheduling activity, due to which we are not able to identify, okay, the project has been delivered late, so we are not identifying it. So this is again another reason why the software has been delivered late. Now for that project scheduling, so what we need to do, we need to divide all the tasks into small pieces. Like all the technical projects which are involved, 100 of small tasks. Like some tasks, they do not affect the project completion, and other tasks, they are critical for the project completion. So what we need to do, firstly we need to break the project into various small portions, that is into various smaller tasks. After that, after dividing all those tasks into smaller portions, we need to identify that which tasks are, if not completed on time, will not affect the project, and which tasks, if they are running late, they will affect the project. And such tasks, they are critical in nature. We can also term them as critical tasks. Okay. So these are the critical tasks which needs to be taken care of if they are falling behind the schedule. Now project scheduling. To schedule the project, a project manager must perform all these activities, like it should define all the project tasks, build a work that depicts their interdependence. We need to identify the critical task and track the progress of these tasks. So this is how the project can be scheduled. Now, there are different views to view this scheduling. For someone, the end date for completion has been finalized, only rough time frame is given. So there are various different perspectives to view the scheduling. For someone, it can be that we are giving a hard bound value. Okay, till suppose 15th of July, your project can be completed, and only rough time frame, like approximate 15th of July, the project can be completed. So where we can have this rough time frame and where we can have this final date. So this, we also need to identify this. In the projects which are very sensitive in nature, like rocket launching, bank dealing projects, all such things, they are need to be completed on time. But rough time frame, like suppose developing a college ERP, or we can say we are developing a website. So these are the things that can be tackled off for 1 or 2 days. So in there we can give the rough time frame as well. Now there are basic principles for software project schedule. So we are having compartmentalization, interdependency, time allocation, effort validation, defined responsibilities, defined outcomes, and defined milestones. So what now, let's see what are these. Compartmentalization, it means define the distinct task. Interdependency, it means the parallel and the sequential task that needs to be taken care of. Aapka time allocation, it is an assigned person in terms of days, the starting time as well as the ending time. Effort validation, it means about the resources which are available to complete that project. Defined responsibilities, like the staff has been identified, now the work should be assigned to those staff. Defined outcomes, that each task it must have as an output, and defined milestone, that is review for the quality. So these are the basic principles for any software project. Now let's see this one by one. Compartmentalization. The project must be compartmentalized into a number of manageable activities, the actions and the task, and both the product and the process, they needs to be decomposed. Now second one, it was interdependency. So what is that? After compartmentalization of each activity, the interdependency of each activity, the action or task, that must be determined. Now some tasks, they must occur in the sequence, while some tasks must be there, they can occur in the parallel as well. So some actions, or we can say the some activities will be there which cannot commence or which cannot start until the work product delivered by the another is available. Like suppose we are having activity A to B. So what does this means? This means that activity B cannot be started till activity A has been completed. Next one, time allocation. So each task, it to be scheduled, it must be allocated on some number of work units. So in addition to each task, we have to assign a start date and a completion date that are a function of the interdependencies. Now, based on this start and the stop dates, we need to base whether the work will be conducted on a full-time basis or on a part-time basis. So this is the advantage of giving this time allocation. Next one, it is the effort validation. So every project, it has a defined number of people on the team. So as the time allocation occur, the project manager must ensure that there is no more than allocated number of people has been scheduled at a given time. Number of persons must be identified, that okay, these are the number of persons, and accordingly only this number of people will be working. If this has not been working, so we can overcome with another schedule. Define responsibilities. Every task that is scheduled, it should be assigned to a specific team member. There should be a particular team member to whom that particular responsibility must be assigned. Defined outcome. Now every task which is scheduled, it should have a defined outcome must be there for the software projects, like for the work project or the work product. So the work products, they are combined together into some form of a deliverable must be there. Now defined milestone. Every task or the group of the task, it should be associated with the project milestone. Every milestone must be there with that particular project. A milestone, it is accomplished when one or more work products, they have been reviewed for quality and it has been approved from the system. So this is the milestones can be defined. Now this is a relationship between people and effort. So if we fall behind the schedule, we can always add more programmers and catch late in the project. So it has a disruptive effect on the project and the schedule slips even further. Now if I say that okay, the project is running behind the schedule, so what most people think is that if the project is running behind the schedule, add more person to that project. Now ultimately what it will be lead, more person means more effort will be there, and similarly the project can be completed. But no, this can never be a complete solution for that, because adding the people later on the project, they can have a disruptive effect on the project as well. Disputes must be there, there will be the scenes that the new people, they are not able to capture the project insights as how it will be working. So it will also lead to an issue, and this schedule it slip even further. So it may be the case that the schedule may slip even further, the project may be scheduled even further. We need to define all these cases. So this is the relationship between people and the effort. People and the effort, the number of people working in the software project and overall productive, it is not linear in nature. Like as we can see in this figure, the saying is that if we fall behind the schedule and we can always add more programmers, we can catch up the project, but this is not the case. So we can say that the relationship between the people and the effort, it is not linear. Fewer people and longer time period, it is a better option for a software development. So what we can give a more timeline. The time can be given far behind from that, but a longer time period with a small number of people, it is much more better option than smaller timeline with a huge team to work upon. Now scheduling. So to make a schedule, there are various tasks that needs to be identified and completed. First one, identify all the tasks that needed to be complete the project. Break down the larger task into the smaller activities. Determine the dependency among the different activities. Establish the estimates for time duration to complete the activities. Allocate the resources to the activities. So as we can see that in these four, what we are doing, we are just identifying the activities. For in the first one, we identify the task. In the second one, we have broken those larger tasks into smaller activities. In the third one, we have identified the dependencies among the different activities. In the next one, we have estimated the time duration for all these activities. So time duration came over here in the fourth one. After time duration, we allocate the resources to those activities. Then we plan the starting and ending date for those activities, and finally we determine the critical path or the chain of the activities, duration of the project. So from that critical path, the duration can be calculated. Now, the first step involves identifying all the tasks which are required to complete the project, and this can be done when the manager has good knowledge about the project and the development process. In the scheduling, in the next step, the larger tasks, they are broken down into logical set of smaller activities which would be assigned to the different developers. So for that, WBS, which is work breakdown structure, it helps the managers to develop this system systematically. So here the scene comes out to be of the WBS. After the larger tasks which we have identified, they are broken down into smaller activities. A WBS, that is a work breakdown structure, is created, and then from their WBS, the manager has to find the dependencies among the various activities. Now these dependency, it determine the order in which the different activities will be carried out. Like for example, if activity A, it requires the results of activity B, then A must be scheduled after B. Like B, the output of B is required as the input of A. That means B needs to be completed much before the A has been started. So this is scheduling. Now once the activity network representation has been done, the resources are allocated to each of the activities, and the resource allocation, it is typically done by the help of these Gantt charts. Gantt charts we have been discussed in the earlier slides as well. Now after resource allocation, PERT is used. What is PERT? PERT is program evaluation and review technique, and here the chart is representation is done. And for the PERT, it is suitable for project monitoring and control, and the time frame when each activity has been performed, it has also been determined. At the end of each activity, we call it as a milestone. What happens in PERT? In PERT, basically what is there in the activity network, we just identify one time period, that is this is the number of weeks in which that particular project needs to be completed. In PERT, we give three types of time period, like pessimistic, optimistic and most likely. So for these three type of time period, after identifying this time period, we calculate the expected time. From that expected time, the activity has been calculated, and from there the milestone is calculated. So this is how the PERT will work. If the project manager observes that the milestone they are getting delay, then he has to carefully control the activities so that the overall deadline it can be matched. Next comes work breakdown structure. Now what is WBS, which we have been talking about? So WBS, it is basically a hierarchical decomposition of the total scope of the work to be carried out by the project team to accomplish the project objectives and to create the required deliverables. So let's see how this WBS will work. WBS, it is used to decompose a given set of tasks to set recursively into the smaller activities. We have a larger activity, and all those larger activities recursively they are decomposed into smaller activities. It provides a notation for representing the major task which needs to be carried out. So the root of the tree, it is labeled by the problem name. Now each node of the tree, it is broken down into smaller activities, and each activity, it is recursively decomposed into smaller sub activities until we come to a leaf level, right? From the root we are going to divide those leaves. From there sub roots are divided into leaf till when we have to do the decomposition, till we reach at the leaf level. Now this is the format for system development projects for any particular WBS. This is the project, this is at the WBS level 1, or we can say this is at a root level. At the second level, what we are going to do, we are dividing project into various activities like hardware, software, system engineer, project management, system testing and database management. So how these numbering has to be done? This is level 1. At level 2, what we are going to do? 1.1, 1.2, 1.3. Similarly, we will be doing. At level 3, this 1.1 will be divided into sub further activities. So what will be there? 1.1.1, 1.1.2. Now suppose this activity has to be divided further into sub activities, the numbering will be 1.1.2.1, 1.1.2.2. Like here 1.2.2, it is divided into 1.2.2.3. So this was 1, this was 2, so this comes out to be 3. So this is how numbering has to be done, until where we have to do the numbering, till we reach at this leaf level. So what we can identify, that if I am having this number, so I know that what is the path. The path is the firstmost activity, which is the root level. The root level, it is divided into another sub root, that is at the second activity, second sub part, and its third activity. So here I can identify, okay, this was the activity which we were talking about. So now a work breakdown structure, it is a fundamental project management technique for defining and organizing the total scope using a hierarchical tree structure. Now the first two levels of the WBS, that is these levels, level 1 and level 2. So the root node and the level 2, they define a set of planned outcomes that collectively and exclusively represent 100% of the project scope. Now at each subsequent level, the children of a parent node, they are collectively and exclusively, they represent 100% of the scope of their parent node. So what is a well-defined WBS? A well-defined WBS, it describes a planned outcomes instead of a planned action, and the outcomes, they are desired ends of the project and they can be predicted accurately. The actions, they comprises of the project plan and they may be difficult to predict accurately, and a well-designed WBS, it makes it easy to assign any project activity to one and only terminal of the WBS. So this is a particular breakdown structure. From here it can be worked upon. Now when we are able to complete this drawing of the WBS, so each WBS, it should contain the 4 items. Now what are those 4 items? First one, it is the scope of the work. Along with the scope of the work, the deliverable must also be included. Second one, it is the beginning and end dates for the scope of the work. Third one, it is the budget of the scope of the work. And fourth one, finally, the name of the person who is responsible for that completion of the work or who is responsible for that particular scope of the work. This is a WBS for a MIS application. So for this MIS application, the MIS application is divided into further sub-activities like requirement specification, design, coding, testing and documentation. The design further divided into database part and the GUI part. Similarly, the code is divided into database part and GUI part. So this is how the MIS application problem WBS can be created. Now WBS levels and numbering. So what is the code assigned for each activity? Like level 0, it is the project itself. Level 1, this is the major deliverable. Like the major deliverable over here, it is requirement specification, design, coding, testing and documentation. So this is at a level 1. Level 2, individual components of the deliverable. Like here, the database part and GUI part, it comes out at to be the level 2. And the final level, it is the work package which will be delivered, that is at the leaf node. This is a numbering system like 1.0. The project, it is the overall project under development, that becomes level 1.0. 1.2, which is in the yellow color, 1.2, 1.3 and 1.4. This is the deliverable and the major components. This blue one, 1.2.1, 1.2.2 or 1.3.1, 1.3.2, these are the sub-deliverables that are supported the deliverable, and these green ones, these are the work packages, they are the individual project activities. Now, along with this, there are various types of WBS as well. Now, first one, it is the verb-oriented WBS, the project-based or the task-based. So, a task-oriented WBS, it defines the deliverable of a project in terms of the actions which must be done to produce that particular product. The first one, in the verb oriented or project one, it must be a verb like a design, develop, optimize, transfer, test, etc. So, this is again the level will be same as we have discussed. For this, if we are going to make a verb based, so like requirement analysis, numbering will be 1.1, 2, 3, 4 along with it. Requirements analysis, stakeholder, design, prototype development. The second one, it is the noun oriented, or we can say the deliverable oriented or the product based. So, a deliverable oriented WBS, it defines a particular project or a work in terms of the components or the physical or the functional. So, that comes out to be a noun only that make the deliverable. Like in this case, what we are having module 1, module 2, module 1. So, these are the name of those modules which we are going to develop. So, in this case, the first word in a given WBS element, it is the name of a noun like module A, subsystem A, automobile engine, antenna, etc. Since the nouns, they are usually a part of the product. So, this WBS, it is sometimes it is known as the product breakdown structure as well, which is PBS. So, if we are dealing with the noun, that becomes to be the product work breakdown structure. If I am dealing with the verbs, that becomes out to be the verb oriented work breakdown structure. Thank you.